For 12,000 years, the Haile Gubi volcano in Ethiopia sat completely silent. Then, on November 23rd, that silence shattered. The blast was sudden and powerful, heard clearly from cities over 100 miles away. It punched a massive cloud of ash 50,000 feet straight up into the atmosphere, creating a plume so dense it was easily visible from space. This map of the Indian Ocean tracks that debris field as high-altitude winds carried it east. The ash swept over Oman and Yemen, crossed the Arabian Sea, and eventually choked Indian airspace, forcing mass flight cancellations in cities like New Delhi. Flying through a volcanic plume is a massive risk. The cloud is packed with microscopic, jagged bits of rock, crystal, and glass. If these particles enter a jet turbine, they can melt and seize the engine. On the outside, they act like high-speed sandpaper, scouring the cockpit windows until the pilots can no longer see. A localized eruption in a remote desert has the power to disrupt transcontinental travel and ground air fleets thousands of miles away. To find the source of the blast, we have to look at the ground zero, a desolate stretch of northern Ethiopia called the Danakil Depression. This is the hottest place on Earth. The valley floor sits well below sea level, baking in temperatures that routinely cross 55 degrees Celsius. But the true heat comes from below. The entire landscape is geologically hyperactive, dotted with toxic, neon-colored acid pools and open lakes of boiling magma. Reawakening a volcano after 12 millennia requires massive geological energy that is being generated by a specific mechanism moving beneath this valley. To find the source of that pressure, we have to look past the surface and into the movement of the Earth's outer shell. This map isolates the crust beneath Ethiopia, a geological triple junction where three massive sections, the Nubian, Somali, and Arabian tectonic plates, all meet. These gigantic landmasses are actively tearing away from each other, thinning and weakening the crust directly above them. They are migrating outward at a rate of 2 to 5 centimeters per year. For a sense of scale, that is the same speed your fingernails grow. The Haile Gubi blast occurred because highly pressurized magma found a newly thinned weak point in the tearing seams of the crust and punched its way to the surface. This map shows how that central tear extends far beyond Ethiopia. It forms the East African Rift, a massive fault line stretching 6,000 kilometers south through Kenya, Tanzania, Malawi, and Mozambique. The stress of this continental tear shaped the region's geography. Massive landmarks like Mount Kilimanjaro were pushed upwards by the shifting plates below. The continent is cracking so deeply that vast trenches have opened up along the rift. Over time, water has pooled in these sheer drop-offs, creating deep lakes like Lake Victoria and Lake Tanganyika. This massive 6,000-kilometer scar marks the line where the African continent is actively pulling itself apart. To understand where this leads, we can look back millions of years to the breakup of the supercontinent Pangaea. This map shows the Arabian Peninsula and Northeast Africa locked together as a single landmass. As the plates drifted apart, they tore a massive trench. Ocean water flooded the gap, forming the Red Sea and Gulf of Aden. The current fracture dividing East Africa is an exact repetition of that ancient cycle. It is the mechanical process of a new ocean being born. This map models the rift 5 to 10 million years into the future. The eastern section of Africa fully detaches, and the Indian Ocean rushes in, separating the Somali plate into a new island continent. We are currently sitting in the real-time infancy of that new sea. The timeline spans millions of years, but the tearing is visible today. In 2005, right along the Ethiopian fault, a 60-kilometer-long trench ripped open the desert floor in a matter of just 10 days. Those deep, calm lakes dotting the rift valleys are effectively the early, shallow beds of this future sea. Every grounded flight, every sudden desert fissure, and every volcanic explosion in the Danakil Depression is the sound of the Earth rewriting its own map.